Hey Geometry, this is section 9.3. We are going to continue on talking about circles and arcs of circles. I'm going to go give you a little bit of background of what we've been doing and talk about the different measurements that we have for an arc. Okay, so an arc in a circle is, something like that. It's like the crust of a pizza, right? So the different measurements that we have for an arc, we can either measure an arc in degrees. So like this arc might be, I don't know, I didn't do a very good job of drawing. Let's say that arc is 100 degrees, okay? Or you can have a measurement for the length of the arc, in which case, like if we have that the radius is 5, we do arc length by doing the entire circumference of that circle. If the radius would be 5, then the entire circumference would be 10 pi. And then I take 10 pi and I multiply by just the fraction of the circle that I'm talking about, because I'm not talking about the whole circumference. I'm talking about just 100 degrees of it. So I take it times 100 over 360, okay? And then I can figure out what the length of that is. I don't know, something like 10 times 5. Something like 8.7, we'll go 8.7 units is how long that is. So in degrees, it's 100 degrees, yes, but in actual length, we would incorporate the circumference into that, and we get 8.7, okay? So that's what arcs are. Now we're going to talk about an arc intercepted not by an angle, but by a chord instead. And we've talked about chords before. So like we have a circle. I'm just going to use their diagram. Let's do that. So they have this circle, and rather than them doing an angle here to make up this arc, they're instead doing a chord, and they're measuring the arc off that way. So it's kind of like slicing your pizza, but like taking like a piece of like a side of your circle off rather than slicing it in like a regular pizza shape. So it's kind of weird, okay? I'm not going to go through this theorem with you, but let's just go down and let's talk about, this is something called an embroidery hoop. Your moms and grandmas might know what this is, but you put it in a circle and you stitch through this material that's in here. But this is an embroidery hoop, and they have an arc that's going across this embroidery hoop. They kind of get some far-fetched examples here. But they have an arc here, and what you really can't see very well is that there's a tick mark here, and this has a tick mark also, and there's an arc, okay? And the measurement of this arc right here is 60 degrees. And what they're saying, or what the concept that they're trying to get across, is that if you have a length here of a chord that's the same as the length of this chord, the arc measurements, like from here to here, that will be 60 degrees as well. Like, that just makes sense, right? If this length is the same as this one, then the arcs must be the same, right? Like, that just has to make sense. So they say find the measure of arc CD. That's just going to be 60 degrees, okay? That would only make sense, all right? Let's go to the next example, and they have this here, and this is kind of the backwards form. So they're saying, okay, now these arcs are the same measures, right? And they say the length of this chord is 2x plus 1, and the length of this chord is 3x minus 7. So now they're saying the arcs are the same. So now find the measurements of the chord. Rather than up here they were saying the chords are the same, now find the measurements of the arcs. Well, if the arcs are the same, then we can just set those equal to each other. So we have 2x plus 1 equals 3x minus 7. And we just solve, right? So I'm going to subtract the 2x over and add the 7, and I'm doing those both at the same time, and we get 8 equals x, and that's what I get for x. Now, go back up and reread. We have those figures. We have that these arcs are the same. They want us to find PQ, which is the length PQ, okay? Now, I know that that's the length PQ, like the chord PQ, and not the arc PQ. That's what this would be, right? This is arc PQ. This is length PQ. So keep that in mind. That's how they will denote those. So PQ is just going to be 3 times 8 minus 7. 3 times 8 is 24, minus 7 is something like 17. That's how many units PQ would be, okay? So just doing stuff that basically at this point makes sense to do, okay? All right, now, let's see. If a diameter or radius of a circle is perpendicular to the chord, then it bisects the chord. Okay, this is what they're saying for this example. If we have this diameter across here, and then we have a chord that's going through it, and it is intersecting at a 90-degree angle, meaning they're perpendicular. What's going to happen is this length right here is going to be the same as this one. There's no other way of me writing it. They don't have to put the tick marks through there to say that those are the same, but if they're perpendicular, that has to bisect, or that has to split these exactly in half. That's just the way that it works, okay? In the same way, let's see, they do the opposite, the perpendicular bisector of a chord. So they're saying that if this is bisected or split in half, it's making a perpendicular with the chord or with the diameter or the radius. So if it's bisecting, then it must be a 90-degree angle. Versus if it's making a 90-degree angle, then it must be bisecting. So they're saying the same things, but just reverse. That's called the converse of it. And, you know, we're just talking about it splitting the thing in half. It makes kind of a T is the way that I think about it. So it's cutting it and making a T at a 90-degree angle, and it's splitting that T in half, right? So here it says that in circle S, arc PQR, so this all the way across here is 98 degrees, okay? They want us to find the measure of arc PQ, so just from here to here, okay? Now, one thing, it looks like it is splitting in half, but let's talk about why. So this is perpendicular to this one, and when that happens, when you have a radius that's perpendicular to a chord, it's going to split it in half. So they're saying that this length is 6, which we aren't actually using in this case, but we would know that this would be 6, and then we could find the length or the measure of that arc here, not by using the 6's, but by splitting the 98 in half. So this is going to be like 49 degrees. And then this arc would also be 49 degrees. So it's going to separate these two pieces into chunks, and it's going to make the arcs exactly the same length as well, okay? Because it's splitting in a 90-degree angle. Okay, it's making a T. All right, let's go to the back side. We'll go through a couple of these examples. This one's going to be a little bit harder of an example, so pay attention to this one. We're doing like a stained glass window or something here, and it says GH, which you can't see very well, is 30 inches, and that is the diameter. So GH, let me get a different color in here. GH is going all the way across the circle, and that is 30 inches long, okay? From end to end, that's the diameter, 30 inches long. And then the chord, KM, is perpendicular to it, so it's making a 90-degree angle, and that is 22 inches long, okay? So this chord is 22, and the entire length of the diameter is 30, okay? They want to know what JL is. JL, this is kind of confusing. JL is this little bit right here, okay? All right, some things that I know is that if this length is 22, watch my diagram because I'm going to be marking this up a little bit and erasing, okay? So that length, this squiggly mark length, if that's 22, I know that each of these pieces is 11 because it's cutting it in half at a 90-degree angle, okay? So those two are going to be both 11. Now, I also know that if this diameter is 30, then the radius is 15. So like this would be 15 and this would be 15 as well. Okay, now this is a little bit far-fetched, and this is the tricky part, and you're going to probably experience a problem just like this in your homework assignment, so pay attention to this, okay? If I know that the diameter, which is from here to here, is 15, or from here to here is 15, right? Those are all the diameters. I can also draw a diameter, or not a diameter, a radius. Sorry, radius is 15. I can also just like rotate this radius around over here so that it's making a right triangle in this position, which is kind of interesting. So I'm going to create a radius where there isn't one already, and I'm going to call that 15 because that's what the radius is. And then I know that this bottom side is 11, so they're asking me to find JL. That's just that third side of that radius, okay? I'm going to chunk him out over here so you can see him a little better. So that JL, again, this is that like little chord part right here. We're making this into a right triangle. This is a radius, and this is 15, and this is 11, and this is my right right angle. So we're trying to find that JL length, and all we do is the Pythagorean theorem from here, okay? So I'm going to call my question mark A, because I know that 15 has to be, excuse me, C. It's the hypotenuse side. So this is B. We've got A squared plus 11 squared equals 15 squared. I don't think that's a perfect Pythagorean triple. There's not really 11 with any of the good triples. So 121, 225 is 15. If I subtract the 121 over, we get A squared equals 104. And if we take the square root of that, it's like 10.1 maybe, or something like that. Let's see what we get. 104 squared root is, yep, 10.2. I was wrong. A equals 10.2 if we round correctly. So that is what this JL length right here will be. So that was a little bit of a far-fetched example just because you had to create a radius here where there wasn't one already, okay? But just mark up your diagram, you know, and use the Pythagorean theorem at a certain point, okay? All right, theorem 9.5 says, in the same circle or congruent circles, two chords are congruent if and only if they're equidistant from the center. So they're talking about this chord and the length of it in comparison to this chord. And that is only true if this and this distance are exactly the same. So if this distance is 7 and this distance is also 7, then this chord is going to be the, right here, this chord is going to be the same length as this chord, okay? Versus, let me draw you a diagram of one that is not the same. Let's say here's my center, and let's say this is 3 units away. Okay, there's my chord there, and that's perpendicular. But this one is like 7 units away, right? This chord is going to be a lot shorter than this one just because it's further out in the circle. So you can kind of see how that you know, would work. It doesn't matter where these sections are rotated around the circle, like this direction or this direction. It's just if those lengths are the same distance from the center, then the chords are going to be the same length. Okay, so let's go down to this diagram, and we have this one here. It says that WX, which is this chord here, and XY, which is this chord here, each one of those is 22 units. So I'm going to go 22 units, okay? Now we know that since this is perpendicular, it's splitting it in half. So each of these is 11, 11, 11, 11. That's what those look like, okay? And they are asking for find AB. AB is just this right here, which is labeled as 5x, okay? Now, I know that we just did the Pythagorean theorem before and we like looked closer into this triangle, right? But that's actually not the approach that we want to use in this case because we don't know this radius value here. We don't know that thing, but we do know that if this is the same as this, then these two lengths are exactly the same. So we can just set them equal to each other and solve, right? 5x equals 3x plus 4. So sometimes there's multiple ways of doing things. It's just like given the information that you have, which approach do you use? So kind of, you know, fill out all of your information and then go from there, okay? So I'm going to subtract the 3x. I've got 2x equals 4, x equals 2 if we divide, but don't stop there because we have to plug back in somewhere probably. AB, we're plugging into this one. So 5 times 2 is going to be 10 units. And yeah, so different than what we did up here. It kind of looks like a similar diagram, but just because we were given different information, we had to use a different approach. So keep that in mind. I'm going to not do example 6 with you because to construct, we would have to use compasses and all that good stuff, and I can't do that while I can't see you. So we'll stop with example 5, but on the homework, on skills practice, do odds for 9-3, and on practice, do all of them, okay? There is a story problem. Actually read it, go through it, see if you can figure it out, and go from there, okay? I probably will maybe have you turn that in tomorrow with my sub. I think it's Mrs. Arms. And then I'll have her give you the notes and stuff for 9-4, and we'll go through 9-4 notes tomorrow. Okay?